place to start is to understand what do we mean by this growth in bandwidth. So that when we're in discussions with network operators, we typically hear 35 to 40%, 45% annual growth in the data. And what that means is networks have to grow somewhere between, well, they have to grow tenfold, somewhere between 6 to 8 years. So huge bandwidth growth in networks, and this is really driven by huge investment in things like 5G, in the vision statements that countries have, places like Saudi Arabia with their Vision 2030 projects, for example. This is really driving a rethinking of networks to cope with capacity today, but also to re-architect for this future. So all these networks are underpinned by fiber optic cables and optical networking technology to carry data over those networks. And that's what we do at Infinera. We push the boundaries of optical networking. We get the most out of fiber. But this is our latest digital signal processor chip. It's the device we use to really drive the best out of the optics. And this chip has 5 billion transistors in it. And to put that in context, about 10 years ago, we maybe had 100 million, that kind of size. So we have a lot more raw processing power that we can use to manipulate the optics and really drive the best out of the fiber. So today, we're shipping 800 gigabits per second lasers. This chip actually does 2 of them, so it's a 1.6 terabit chip. And we can get terabits of capacity over fiber over very long distances. So interconnecting data centers over thousands of kilometers, subsea networks, for example. And this is really helping to drive and underpin networks today that can scale for the future that we need. As you move closer to the edge of the network, you get a very different challenge. It's still underpinned by optical networking. You still have fiber connecting most of this infrastructure together. And here you have a very different environment because you're pulling traffic together from Internet of Things in smart cities, all these kind of projects. There's huge investment going into these projects across the world, but also in the Middle East. And these networks are going to be very different in terms of how that optical infrastructure is built. And it's really built about pulling data into central aggregation points. And one of the challenges the optical networking industry has had over the last 50 years since optics was invented is it's a point-to-point technology. You have one laser at one end of the fiber, the same speed laser at the other end, and you build your network up on these point-to-point segments. What we've done at Infinera is we're just bringing this year brand new technology to market, which is a point-to-multipoint technology. So a single laser can talk to multiple end locations. And this is proving to have a huge impact on how you can potentially build these modern, advanced, high-capacity networks. So some of the modeling we've done so far showing anything up to 70% savings in terms of the cost of building the network. But this is our 400 gigabit per second. It's called a TROSA. It's a transmit, receive, optical subassembly. And this is really important because this is taking this 400 gig technology right down into pluggables, into little things this sort of size. And again, a few years ago, this would have been a complete rack of equipment, bigger than me, and now it's this size, 400 gigs, but equally this is also one of these point-to-multipoint optics. So this 400 gig optic can talk to up to 16 25 gig optics at the edge of a network, which is a real different paradigm in how you can architect networks.